Hi, everyone. My name is Bill Wells. I'm going to introduce to you Peter Berkey. Peter Berkey is a retired public school teacher. He taught math, physics, and astronomy at Fenville High School for over 30 years and was adjunct professor of astronomy at Hope College. He trained at NASA and is a founding member of the Shoreline Amateur Astronomical Association. He received his BS from the University of Michigan and his master's in science education from Western Michigan University. Peter will be telling you, among other things, about the new telescope that's being installed at Hemlock Crossing. It's quite an exciting thing. It's going to be a 16-inch telescope, so he'll bring you up to date on that. Peter, take it away.
Thank you very much. Welcome, everyone. Thank you for coming today. Okay, that was a good introduction, so I can skip that part and go right to here. All right, just so I can get an idea of the group, raise your hand if you've seen ever the moon. All right, how about if you've seen a first quarter moon? All right, good. And how about if you've seen a lunar eclipse? Oh, good. That's impressive. All right. Next questions. How many own a telescope? Oh, a few people, good. And can't read that one. Oh, I know. How about binoculars? How many have a pair of binoculars that you use for astronomy? All right, that's good. How many have ever seen the Northern Lights? Okay. How about a meteor? All right. How about a lunar eclipse? Did I say that one already? I think I was saying, how about a solar eclipse? Ooh, that is impressive. All right, which solar eclipse did you see? Yeah, I think it was 2017. Is that the same thing with everybody? All right. How about how many people have seen the ISS flyover? Good, good. How about a comet? How many people have seen a comet? Wow, you guys, I'm working with an experienced group here. How about how many of you took astronomy in either high school or college? Actual astronomy class. How many of you are a professional astronomer? No? Okay. How about how many people watch the moon landing on television? All right. And how many have actually met Carl Sagan? I just threw that one in for laughs. Okay, good. Well, I'm here to tell you some stuff about astronomy. And this is astronomy for amateurs, so I'm going to try not to get too technical. But I am also going to try to enlighten you and introduce you to ways that you can enjoy the science, okay? Because it is a very, very multifaceted endeavor. And astronomy, of course, is the oldest of all the sciences. Everything, look around this room, everything you see, including the carpeting and the lights and the desks, everything is because of astronomy. Because astronomy in the 1600s, you probably know or have heard the stories about Galileo and Copernicus and Kepler and Tycho Brahe. Those are the guys that first figured out that the sun didn't orbit the Earth. The Earth was not the center of the universe. Of course, Galileo was thrown in jail for 10 years or actually it was house arrest for making such a radical statement that the Earth orbited the sun. But eventually we did figure that out, and we learned ways to prove our conjectures. We developed instruments such as telescopes and so forth to study the stars and the constellations. And one thing led to another during the Industrial Revolution, and science continued, even though, you know, just about every new concept in science is met with resistance. Okay. And it takes a while. Just for example, what I just said, the Earth goes around the sun, you know, and everybody didn't just go and say, oh yeah, well, that's interesting. No, they rioted and said, no way, and threw them in jail, like I said. But after a while, with more evidence, it was undeniable. And one thing led to another in the Industrial Revolution, and we are here, we are today with the computer generation. So that's where I'm coming from in this class, that I expect that you have a certain amount of basic knowledge, but I want to try to help you expand that in ways that are possible. Okay, I don't expect anybody to go out and buy a telescope. Oh, I'm sorry, could I get that tape measure off the, didn't mean to leave that there. There's the clock. All right. So first thing I want, let's see, did you all get a handout with that has my notes on it? So as you can see on the handout, the first thing, if you want to start getting into astronomy, there are so many different facets of astronomy. You know, you could be an astronomical archaeologist. Guys that explore caves and look for markings from ancient people that indicate, well, you know, they have drawings of the moon and stars in different examples. And, you know, those types of drawings date all the way back to ancient Mesopotamia 10,000 years ago. So we have a lot of evidence that indicates that people have been looking up at the sky for a very, very long time, probably for as long as they have been able to look up at the sky. And for most of that time, they wondered what was going on, because it was just full of mysterious things, some of which you've probably seen. Okay, a comet is a mysterious thing. All of a sudden, out of nowhere, think about, you know, 1,000 years ago, you're out on your nightly trip to the barn to take care of the cattle, and you look up and here's this, what? This thing, this streaky thing that's just sitting there. And you wonder what it is. And the next night it's a little bit further and over, and then it disappears. And you know, there was a lot of mythology made up about comets being visitors, mysterious visitors. Other things also, planets that move from day to day, night to night. Well, those were so mysterious and so important and so well known and easily recognized that they became gods. Okay, so the planet Venus was named after the goddess Venus. Mars, Jupiter, these are all Greek gods. So what was the difference? Why did the people think that these planets, as we now call them, wanderers was the early name that people gave them because of their motion? And now I forgot what I was going to ask about that, but that's okay. Ancient people found so much mystery in the motions of the planets. They could not explain what was going on and why. What was the point? So like I said, their explanation was that these were godlike figures, and they were highly worshipped. And in fact, on a lecture that I give more during the Christmas holidays, there's a whole thing about the Christmas star. There have been articles written about what was really the Christmas star. Some people, some astronomers hypothesized that it was actually a supernova explosion. Star blew up and all of a sudden it was very bright and then dimmed out. Now, I'm not here to argue one way or the other, or even mention about, the star of Jesus, but people in those days had no idea, and so they gave very great importance to any such activity that was unusual in the sky, like a comet or a meteor or planets. So, as I said, everything we have here today, all of our technology, is because of science, and science originated with astronomy. So, when it comes to, let's see, could I have a copy of the, well, you have it. Thank you, sorry. All right, so you have the first two pages. Of writing. This one. There we go. Oh, I'm sorry. I forgot you had my back, right? Sorry. Thank you. All right. So if you want to start getting into astronomy in a more serious level, then the first thing you need to do is go outside and look up at the stars. Now that sounds pretty trivial, but look up at the stars with an educated mind, with some background knowledge. Okay. I probably don't have, considering the number of hands that were raised, I probably don't have to give you a lot of information on how do I find out what's going on in the sky, because you Google what's going on in the sky and you'll find out. You do have in your handout what's called a sky calendar, the Abrams Planetarium sky calendar, which, if I could borrow this a minute, right? This is a good place to start with astronomy, for observing astronomy. And this talk really is geared toward people that are not just interested in astronomy, but you'd like to get out there and actually look at something and know what you're looking at. Okay, let's see a sign of a, or a show of hands for, am I close on that? How many people would like to know how to get out and where to go and what to look at? Good. Because you can go to the library and learn all sorts of stuff about astronomy that I'm not going to mention here. So let's start with the Abrams Planetarium Sky Calendar, which I strongly recommend that if you are interested in this, subscribe to this baby. It's $12 a year. It is a good cause. Abrams Planetarium at Michigan State. And it's really a cool thing. On one side, you have clearly the calendar, and it shows for each day what's up in the sky and what to look at. So it looks like at the beginning of the month here, they have the diagram of all of the major constellations and the stars. On the left-hand margin is an explanation of events to see during the month, especially focusing on planets. You'll notice that in many of the squares, many of the dates, you have a diagram that includes moon and planets. not very many diagrams just show you constellations. Okay, because the sky calendar is more focused on unique events, not things that you see every night. Okay, so for example, when two planets are very close together, or you can see down at the later on at the end of the month, there's going to be a grouping of a thin crescent moon and some planets. Okay, so this is very helpful with naked eye, and I recommend if to start your observing experience, naked eye is the way to go. Look up, make sure you can. Well, first of all, make sure that you know north, south, east, and west. Okay, that's not trivial. I mean, if you're at Hemlock Crossing, where there's no roads, no sidewalks, yeah, okay, which way is north? I mean, you know that the lake is over there, but is it like, so the chart here will tell you it has the directions in the picture. And so if you see Venus in one of those pictures, and you can look down the horizon and see which way to look. Okay, turn that over and you see a diagram of the night sky. Now, in order for this to make any sense, you have to turn it this way to start. And you notice that the directions are written on the around the perimeter of the circle. And it may look weird because if you're looking at it like I am, with north at the top and south at the bottom, west is over on the right. Okay, that's because you look at it like this. Okay, and if I'm looking, okay, then the western sky is that way. Eastern sky is that way. If I'm looking north, okay, this is east, that's west. That's the way the diagram is drawn. Okay, so if you go out tonight and stand and look straight south, what constellation might you see about halfway up? Or actually closer to overhead? Orion, right. And how do you know that that's a constellation and not a star? Yeah, okay, but one in every group. Okay, down here though, you see where it says Sirius, Procyon, Castor, Pollux, and all that, all those names. Okay, are those constellations or stars? Stars. Notice that the constellations are in all capital letters and the stars are lowercase. It may seem trivial, but sometimes it does get a little bit confusing. Okay. And so this is pretty much self-explanatory. There's a very good explanation at the bottom. I encourage you to use this, and just it's a good starter to help you orient yourself with the sky. Now, once you get used to looking at things with the naked eye, then get the binoculars out and look at it with the binoculars. Now, I want to try to demonstrate this, but demonstrating and holding the microphone at the same time are not necessarily simple. So here's what you do with binoculars. You're looking at a sky, looking at it. You want to look at this star or this planet. Okay, so you look at it, and then I'll demonstrate what to do. Aiming at. Just going like this and then searching around. That's a lot more difficult. It's okay. Keep your eye on the object and bring the binoculars up to your eye. Sorry, my fault. And then finally, once you've navigated your way around the sky and learned where some stars and constellations are, and have honed your experience or in your your abilities with the binoculars, then it's time to move up to a telescope. Now, moving up to a telescope is like a quantum leap because not everybody has a telescope sitting in their basement. So the first thing you would need to decide is what kind of a telescope and how much you want to pay and so forth. So is there a way that I have a whole set of slides on different types of telescopes? Thank you. I will. I have examples of different kinds of telescopes up here and back here. Ooh. Yes, please. So you have a backup. If you're not able to, I have the real thing. It's okay. I'll just continue. Okay, is there any way you can do like a slideshow? Oh, sorry.
That's okay. If you tell me which telescope to highlight, I will.
Sure.
Work that one out.
If this is a directory, just double click on each of the images, then close it and go to the next image. And that's what'll
There
fill
we
the screen.
Well, we have the three main types of telescopes up here. Refractor, reflector, and weird. This is though one of the cutest little telescopes. This is a great telescope. It's from Edmund Scientific. I don't remember the name of it. Yeah, Edmund Scientific. And the nice thing about it is this is it. You can carry it in a backpack, put it on the hood of your car, and you want to find something, you just go like this. And it's got real nice motion, no friction or very little friction. So it's easy to push. And if you do get one of these though, I do recommend, I think it goes here, a little finder scope. Now, this is an example of a finder scope. And what happens is this is a much wider field of view, smaller magnification. So you can see a lot more stuff here. So the first thing you do is looking through this eyepiece, you line the telescope up and try to find what you want to say. You want to find Mars. Okay, aim this thing in the vicinity of Mars and then look here and do the final adjustment through the eyepiece.
Could you switch
Okay,
the view back
differences
to
in
the
types of
classroom?
telescopes. This is a refractor. It uses lenses to form the image. Now, all telescopes will have a main tube with either a lens or a mirror, but then you have to have it's sort of like the telescope forms an image and then you use a magnifying glass to look real closely at that image. And the magnifying glass is the eyepiece. Sorry, this is the finder scope for this telescope here. This is the eyepiece. The reason the eyepiece is at an angle like that is because if you tried to look straight through it, you'd have to get down here, and that's very inconvenient. Even if you have this up like this, you'd still have to do this kind of thing. So on most refractors, you'll see a eyepiece such as that at an angle. Now, the advantage of this is they're inexpensive, comparatively speaking, light, easy to transport, easy to set up. The disadvantage is hard to find stuff because hard to explain that. Okay. Hard to find stuff is one way or one negative. Another one is the length of the tube and the amount of motion that is required. When you're looking for stars through a telescope, you have to move the telescope a tiny amount because the telescope is looking at a tiny part of the sky. Okay, you can't just do like that. I mean, you're going to get the star in the field of view, and it's almost, well, first of all, you have the rotation of the Earth. So in about a minute, the object in the field of view is drifted away. So you constantly have to keep moving. Okay. Now that's true with all telescopes, but it's just a little more complicated with a refractor. These two are actually both reflectors, so they don't use a lens. They use a mirror. In fact, two mirrors, at least, sometimes more. And what happens in both of these, you can see it a little better in this one. I don't know, can you actually see yourself in there? Okay, so that mirror is located way in the back of the telescope, back here. And what happens is light enters the front, hits the mirror in the back, is reflected, but is also concentrated and focused and sent back up here. There's another little diagonal mirror right down there. And this is where you put the eyepiece, and this is where you look in. And this is, I prefer this type of telescope because you don't have to go around to the other end to, like that one, to adjust the focus or the eyepiece. Everything is right up here, and it's very simple. If it's not in the field of view, just a little push there, just a little bit. So I would say that for amateur astronomers, this is probably the most popular type of telescope. This one I just brought along to as an example of a different kind of telescope. This is more of like a backpacker almost. You know, you can fling it over your back, and you can on this stand, you can put the stand anywhere. You could place it on a rock and just set the guy there, and away you go. But it is also, the optics on this telescope are the same as the optics on this telescope, are the same as the optics on the Hubble Space Telescope. So all reflectors work like that. Any questions?
Can I just say that Herrick Library,
How many people own telescopes? I asked that before, didn't I? Okay.
I
I
heard
wouldn't-
somebody overhead, somebody unmuted themselves at home and was going to ask a question, but we're not hearing it very clearly in the classroom. Can you go ahead and speak up and ask again?
I sent it in the chat to you.
Okay. I've got about 40 things in the chat right now, so let me look.
It was about Herrick Library having telescope like the red bulb to check out.
so,
that
yeah,
Peter
Herrick
donated.
Library has a telescope you can check out. So I'm assuming you mean like checking out like a book from the library. Do you agree with that?
Correct.
So
this
the-
was checked out for the Herrick Library.
okay, so he said that the red one was actually checked out from the Herrick Library. So that is a really good to know. Thanks, Karen. Someone asked in the classroom, how much does this weigh?
Not much. Not much. Maybe 10 pounds, I don't know, but about like a backpack. The big advantage is how easy it is to set up. I don't know if you've been out at the Holland State Park, my astronomy club does programs at Holland State Park. And there will be many members with a wide variety of telescopes. And some of them, it will take 20 minutes just to set the telescope up because it has a big tripod and you got to align everything. This one is very simple. That's the big, it's portable and easy to use. That's its advantage. You don't use it to take astrophotographs. Any other questions? Yes. Ooh,
In round numbers, how much does each of the telescopes cost is the question.
I think the last I knew, this was about $250. I don't know. This looks like a home built. Not this. They bought the tube, but this is plywood that's painted. So I think the base was home built, and I couldn't tell you what this was. And I'm really not the person to ask about these either, but I'm guessing probably more like 500 to 1,000. Now, of course, there's a lot of variables. You can spend easily 20,000. Okay, like the telescope in the observatory at Hemlock Crossing, the new observatory. I think we spent somewhere in the neighborhood of $20,000 on that. And that's not that expensive for an observatory type of telescope. So it's a wide range. That's why I always recommend people start with binoculars. They're light, easy to use, and they do a good job. Anything else? All right. So, beginning. Go ahead.
What power binoculars would you recommend?
Good question. Depends on if you plan on mounting them on a tripod. Okay. These are yeah, 10 by 50. So first you have to understand the numbers, 10 by 50. Well, 10 is the maximum magnification and 50 is the aperture, 50 millimeters. Okay. To me, the 50 is more important than the 10 because the bigger the aperture, the more light gets in and the brighter the image. If you have anything higher than a 10 power and you try to do this, whoops, the image is going to bounce around. So too much magnification, you have to have a tripod, which they have. I mean, that's easy to do. They have the hardware to hook binoculars up onto a variety of tripods. Did that answer the question? Good, thank you. Anything else? All right. So on your handout, we are now down to, I hope. Yeah, there you go. Number 2A3 was the answer, or the question that just came up. Should you invest in a telescope? Well, pay attention to what it says there. Try before you buy. I think that, like Ryder's Hobby in Grand Rapids carries telescope, and I bet they'll let you look through it anyway. But when you try it, also, do this. Don't just try the telescope. In this situation, this tripod mount's probably just even more important than the telescope. You can have a really nice, expensive, great telescope. You have a lousy tripod, it's worthless because it'll just move around all the time and vibrate. So then that's part B, no cheap tripod, and then start small but steady. And I've kind of spoken to that. All right, resources. Well, there is a variety of resources, one of which is magazines. Two of my favorite. The reflector is more technical. It is the okay, I should know that. Okay, yeah. This is the official magazine of the Astronomical League. So another suggestion would be join the Astronomical League. Lots of great information, notifications on what to observe, when and where. And the magazine comes with the subscription. There's also Astronomy magazine, which you can get at any bookstore, but I don't just subscribe to that one. I subscribe to Sky and Telescopes. You may find that Sky and Telescopes, some of the articles are pretty specifically scientific and technical. Astronomy magazine, at least my impression of it back in the day, was that it's geared more toward the non-science person. There's a word for that I can't remember either. So, books and magazines. Now, you notice on here, Sky Safari and Starry Night. Okay, those are names of astronomy software. Okay. Sky Safari, I believe, is a free, and it's an app that you can load onto your device. And it's pretty cool because you hold this up and you can set the program so that you hold it up and it'll tell you what you're looking at. That's pretty cool. Of course, those of us who toiled with binoculars and lining telescopes up to see what we wanted back in the day, it's this point that's cheating. Well, see, the Astronomical League has a wide world of awards, observing awards. The most common one, well, I shouldn't say common, but probably the first one that most people receive is the Messier Award. And the Messier Award goes, or you get a Messier Award for observing and logging your observations of all 100 and whatever it is, 6 or 8 Messier objects, M objects. Anybody familiar with that term, what I'm talking about, M objects? All right. Mr. Messier was an astronomer and scientist in the 1700s. And in those days, most of the things that folks were looking at were stars. And when you look at a star through a telescope, it doesn't change. It looks like a star. It's just brighter. But it's, if you look at Mars through a telescope, it's Mars. It's not just a dot of light. You can see, the disk. Not so much with stars. There are no stars that you can do that with. They all just look like points of light. Well, Mr. Messier in his survey of the sky ran across these things that weren't points of light. They were light, but they were fuzzy. What's up with that? Fuzzy. And the telescopes at the time, the fuzziness was so fuzzy that it just looked like a blur. So he made a list of all those objects. And since he was the one making the list, he named them and he numbered them. So the first one he saw was Messier number 1, which we now call M1. There are 100, like I said, 106 of them. M106 is one of my favorites. It's a sombrero galaxy. It's beautiful and it's easily seen through telescopes. Just about all of those Messier objects are telescope destinations. And if you Google Messier pin or go to the Astronomical League, you'll easily find out all about all of their observing programs. You do have to have a logbook. You have to log your observations, and then you have to have them okayed by, usually it's the president of an astronomy club. That's what I did. And then you get a nice pin and a nice certificate that you saw all of them. So that's an advantage of being in a club or getting the literature is that you have more exposure to what is out there for you. Any questions on that? How am I doing with the mic? Thank you. Okay, so as I said, Sky Safari, I can actually show you that to you afterwards if you have a minute on my device. Starry Night you have to pay for, and I use it on my computer, and I don't know if they have a mobile app for Starry Night. Yes, sir. Don't know. Sorry.
Is Sky Walk any good? And the answer is, I don't know.
I'm not familiar with that one, but most of those, you can download them and try them out. I would go with the free ones to start with. But sorry, I'm not familiar with that one. Okay, next page. Dark sky. Find a dark spot nearby. Well, easier said than done. I live at 215 West 12th Street, corner of 12th and Washington. It's not dark anywhere where I am. Of course, you go down to Collin Park, but it's not dark there either. So around here, you really have to go south of town. You get down by New Richmond Bridge, the Kalamazoo River, that area, it gets pretty dark. The problem is you sort of, you can't really set up your telescope on somebody's lawn or even in their driveway. So now you got to try to find a park or a public place. So it's not that easy. I recommend Hemlock Crossing. Raise your hand if you're familiar with Hemlock Crossing. Okay, good. For those of you that have not visited, Hemlock Crossing is a county park, Ottawa County Parks, and is about halfway between here and Grand Haven. If you go take 136 straight up, it's right off the highway and right off 136th. And yes, it is a county park, but it's kind of the home of the Astronomy Club because, the members in the Astronomy Club are geographically spread out. We have some guys in Hudsonville, some guys in Saugatuck, others in Grand Haven. And so Hemlock Crossing is kind of a centralized location. And we, once a month, we do programs out there like this once a month. If you're interested, I'm doing a program on light pollution at Hemlock Crossing this Saturday. And they have, it's as far as light pollution is concerned, it's one of the best places around. There aren't a whole lot of intrusive lights at Hemlock Crossing. And there are concrete patios where you can set up your telescopes, and soon there will be an observatory. Okay. And if you go online and go to the International Dark Sky website, it's ida.org, I think. No, I'm sorry, darksky.org. They have a listing of all of the dark sky sites in the country, not in the world. One in Michigan is, have anybody been at the Wilderness State Park? There's a dark sky observatory up there. Good. Okay, and then of course, Part D, self-educate. Well, you're doing that now. Subscribe to magazines such as Astronomy, Sky and Tell. Check out books from the library or online. And the next level up would be join a club. I can recommend one if you'd like. And start an observing project, which I've talked about from the Astronomical League. And yeah, I was kind of hoping that we would be able to just click on that link, because you probably don't want to type in https://www.time.com article/top-12-free-astronomy-software. No, I don't. But the Astronomical League. Go to the, astronomicalleague.com and it'll be easy to find. Okay, if you are at the advanced level, then you can see there again, where I've talked about the awards. Raise your hand if you've ever visited an actual observatory. Good deal. How about the Lowell Observatory? Has anybody done the Lowell Observatory on Arizona? This is really cool. That was where Clyde Tombaugh discovered Pluto. You can actually see the telescope that he used in Flagstaff. Okay. Messier Marathon and national events and conventions. Well, again, you have a web page link for those things. Messier Marathon. My astronomy club used to do that back in the day when things were a little bit different and more guys could stay out all night, but it's usually in March. And what you do is you set up your telescopes and you try to observe all 106 of those M objects. I've never done it, but my club used to do that. I remember once staying out until like 3 or 4 a.m. And I think we saw probably 30, 40, 50 things. But if you are a serious observer, you can get, there have been people that have found all of the objects in one night. I might point out, I don't know if this is different either, but it used to be that in order for you to get your Messier pin, no go-to scopes allowed. You had to find the things yourself. You know what I mean by go-to scopes? For anybody who's not familiar with that, you punch in, I think you can even just probably talk to it. Find Mars. There it is. Okay. I spent a half an hour one night looking for M51. It's beautiful though. It was worth it. And then finally, more resources. Those are all pretty self-explanatory. I like this HQ Spot the Station. That's a NASA, as it says there, website. And you'll get little emails that says, and you can sign up for different satellites. I signed up for the International Space Station. Now I'll get I think I just got one this morning that will tell you the ISS is visible, and it tells you when and in what direction and for how long. And this is pretty cool. I have little neighbor kids, and I just go, this is something you can just see from your backyard or anywhere, because it's bright and it moves. And when you look at it, you say, what is that? Because it does not look like anything else, but it's the ISS. And yeah, they'll tell you, the HQ Spot the Station website will tell you when it's first visible, what direction, where it's, what direction, or from what direction is it visible? Is it coming from? In what direction will it go to, and when it will disappear? And disappear is not physically, but go into the shadow, because the ISS is only a couple hundred miles up. It's not that far away, really. And of course, we can only see it at night, but it has to be lit up. So it has to be daytime on the ISS and nighttime on the ground. So you're never going to see it at midnight. You see it like after sunset or before sunrise. Okay. Because then it's high enough up so that it hasn't entered the Earth's shadow yet, but we are in the shadow, so it's dark. So it's very critical timing, and the website will tell you to the second when it appears, when it disappears, when it's at the highest. Yes. Oh, it's reflection. It's reflection from the sun. Yeah, that's why. That's why when it
Repeat the
goes.
question. Just repeat the question for the people at home,
Oh, the question was,
please.
when you see the International Space Station, is the light that you're seeing, is that reflected off the sun? Because I just talked about it going into the dark part of the atmosphere, or is it lit up? And that's a wonderful question. I can remember it was sometime in the 70s, and I think it was one of the first space shuttle launches. And the same question came up because we watched it go over, and the friend that I was with asked, well, now, I didn't know they had lights on it. I said, no, it's the sun. So, yeah. No, satellites do not have any lights on them. Any other questions? All right. Other observing possibilities, lunar events, those are probably one of the most common. You know, just go out and see if you can figure out what's the phase of the moon is. And do you know if it's a first quarter tonight, how long will it be before it's full? Or will it even be full? Maybe after first quarter comes new. You never know. And then lunar eclipses are much more common than solar eclipses. I think there's one coming up this year. Those are not nearly though as spectacular. Solar eclipse, if you ever get a chance to view a solar eclipse, it's special. It's hard to describe, but it brings on feelings that are unique. And then solar events, sunspots, flares, and eclipses. It didn't come out in red, but at the bottom, it should say, don't do this unless you have a special telescope. Never, ever point anything at the sun, like binoculars or a magnifying glass, or worst of all, a telescope. If you point this guy at the sun and look through it, you'll be blind in that eye in about 2 seconds, even less. So solar telescopes are specially made to only reflect a very teeny part of the sun's light, or they put, you can build a telescope that will not reflect very much of the light, or you can put a cover on it and have a little tiny hole. Most of the guys in my astronomy club, most of the members of my astronomy club would go along with the first kind, the foolproof. So anyway, we spend a lot more time looking at stars and stuff than we do at the moon. Okay, before we move on to some activities, any questions? It's a good thing I didn't leave a half an hour for questions.
You mentioned, is March the best time of the year to see? You had mentioned March. Is it, or is there particular months?
That's because in March, all of the M objects will be above the horizon at one time or another during the night. Okay, that doesn't happen all the time. If you go out in the winter time, it's like this. If you go out in the winter time, some of those objects will already have set. Then you won't be able to see them. But in March.
One other question. When I was growing up, I used to be able to walk outside and see the Milky Way.
Yeah.
And I don't know when the last time I saw it.
Okay.
Can you still
You
see
want to
it?
come to my program on light pollution. That's the only reason. Pardon me? I bet yes, I'm going to say yes, but you have to find some place where it's dark. I would guess that Hemlock Crossing would be a candidate for that. Anything else? Yes.
So what are the Messier objects?
Oh, good question.
You said fuzzy light, but
1 second. So Mr. Messier saw these things, didn't know what they were. They were just little fuzzy lights. Took astronomers a really long time to figure out what they are. So there's several things. Most of them, they're just called nebula. Well, it could be, you know what? Can I show those slides? Rats. I didn't realize.
We tried,
While she's hooking up, dark sky, go to the southwest. We have a mission program in the Pine Ridge Reservation. It's away from Rapid City or any other big city. And the Milky Way is just wonderful.
are you wishing to show your slide presentation? Or are you looking deeper into, okay, yeah, absolutely. You tell me where to
That's a
go.
movie.
While they were doing that,
That.
I
There's a
think
folder
everybody
that's
that signed up for the class received these documents as a download. And you will be able to click on the website in that downloaded document. So if you signed up for this class, you should have gotten all of this paperwork sent to you electronically, and you'll be able to click on the websites in those documents.
Wonderful. Well, however you got that one. Okay. This should be one of many. Just I don't care which one. There's no sorts of order or anything. Just show the rest of them. I don't care. To answer the question, the Messier objects are objects such as galaxies, distant galaxies, star clusters. There's various types of star clusters. Galaxies, star clusters, things like supernova remnants, which is what you saw there. Yeah, that one. This is the Ring Nebula. Okay. And this is the remnant of a star that exploded in 1055 AD. I believe I got that right. The way we know that is because the Chinese back in those days were very, very top-notch observers. They were meticulous in their observations of the sky. And one night they saw a star that wasn't there before. And it got brighter and brighter and brighter for about a month until it was almost so bright that you could see it in the daytime. And then it faded out. And when we look, and the Chinese also were very good at documenting the locations of their observations. And so we know where to look. Well, when we look, this is what that last slide was what we saw, the Ring Nebula. So what happened, what all those people in 1055 saw was, and this was documented, this was, you have Native Americans, South Americans, European astronomers and observers all making notes of this. So it was a worldwide event. And it was the reason a star blew up. When a star blows up, well, there's different kinds. Okay. You can have a star blow up and just completely annihilate itself and it just scatters parts, supernova explosion, nothing left. Okay. In this picture, you'll notice that there is something left. This star blew up, and that's the white dwarf that remained. So this was a star that more or less shed its outer layers violently. These are all the outer layers. So just imagine a balloon expanding very fast, but leaving a little marble in the center. Now, when you look at that through a telescope, this is like a white fuzzy thing, not a star. So we have galaxies, novae, supernova. I got a super. Can we go to? That's Jupiter. Ooh, that's good. This is this was a famous picture. This was one of the first Hubble Space Telescope pictures, the Pillars of Creation. And this was a picture taken in a nebula. I believe this is well, I can't say exactly which one. Thank you. Yes, this is the Eagle Nebula. So it's in the constellation, located in the constellation of the Eagle. And this is actually pillars of gas and dust out of which stars are forming. But when you look at it, it's just a fuzzy thing. Here, this is a really good binocular exercise. And there still may be time this year to see it, because if you look at Orion's sword, not his belt, but his sword, you'll see one of those. There's 3 stars in the sword, right? Hopefully you guys know what I'm talking about, the belt. 3 stars in the belt and 3 stars in the sword. One of those in the sword is a star. Another one is actually a double star. And the one in the middle is the Orion Nebula, which is similar to this. So if you look at Orion's sword through binoculars, you'll see that that middle star is not really a star at all.
Peter, at the bottom of this picture, as you can see, there's icons of, so if you want to direct me to the next picture you want to share.
This one.
Okay.
Yeah.
It's
Cool.
coming up as a dual screen. Let me see if I can make that go away. Okay.
All right. So the one on the right, I forget its designation, but that is a supernova remnant. There is no bright star in the center. It's just blown itself up. Sometimes you'll get a black hole in the center if the original cloud was massive enough.
Okay. Anything else on here you want to
Oh,
share?
everything.
Okay.
Sure.
Well, just point and I will try
Let's
to.
go back to Saturn there over by, it's right next to the one we're at.
Okay, right
Yeah.
here.
This is apparently the best picture ever taken of Saturn in terms of clarity. And I think it was a computer, not generated, but the computer took lots of small pictures and pasted them together to make that one. Now just keep going right over to the right. All right, back to the M objects. Galaxies, supernova, supernova processes, and clusters of stars. Back to that. Yeah, right next to Saturn. So this one. Okay, this is the Pleiades. The Pleiades can be found in the wintertime, probably is still visible. In the southwest, it's between Orion and Taurus. Now, one of probably the most recognizable constellation in the sky is Orion. Belt, sword, arms, legs, shield, and he's fighting against Taurus, the bull. And in between them is interesting stuff, actually. And this is one of them. And this, again, now you might say, wow, this is obviously stars. It's not really a fuzzy, blurry thing, but it does have Messier designation. I forget what number it is. Okay, just keep going one over to the right. Now, raise your hand if you ever heard of Stonehenge. Just about everybody. This is a Stonehenge type thing in Egypt. Many, many thousands of years before Stonehenge. And it's the same kind of thing. It was used as a calendar and to predict things and keep track of the days. Next. Yep. What was I talking about, Orion? Okay, is it easy to turn the lights off, or does that mess up the people at home? Okay. 3 stars in the belt. 3 stars in the sword. And you can't really see in this picture, but this is the Orion Nebula, which is not really a star. Next. Bottom right. Betelgeuse is a red giant, and you can actually see it's reddish, kind of looks reddish. And it's this one, and then Rigel at the top left is that's totally backwards. Betelgeuse is at the top and Rigel is down here. Sorry. All right. Go right to the next one. Okay, I got 3 pictures of the Andromeda Galaxy. Okay, can we get the lights off again? Thank you. The Andromeda Galaxy is the only it's the only galaxy that is visible to other than the Milky Way. It's the only other galaxy visible to the naked eye. Every other galaxy you need a telescope to see. So this is it's a spiral galaxy. Go to the next slide, please. It's very similar to our Milky Way. It's got a central core, which I believe astronomers, there's a lot of evidence that there's black holes or a black hole at the core of many galaxies. And then the spiral arms. This is all gas and dust. It's like 99% hydrogen, 1% helium, and other stuff is all the rest, because that's what the universe is made of. The dark streaks you see in there are just like places where there aren't as many stars. And if we were able to look at it from above, it would be like a pinwheel kind of shape, just like the Milky Way. This guy and this guy are satellite galaxies. They're gravitationally attached or connected to the Andromeda Galaxy, but are totally separate from it. Yes, sir. I was afraid you guys would have that.
Where in the sky is the Andromeda Galaxy?
I don't know. Right? Did you find it on here? Or you just know that? It's on there. Ah, Mr. Berkey should be more familiar with his presentation. Whereabouts? There you go. Oh, that's right. Oh, that's okay. I remember this now. Remember Cassiopeia, the W looking one? If you go to the right hand side, like a W is 2 V's, okay? You take the right hand V and pretend it's an arrowhead pointing down, it'll point right to the galaxy. That's the way you find it. Next. This is the same image taken at a different wavelength. I believe this is ultraviolet. Next. This is what is this? The moon. Ah, not Mars. And you can see some people see a dog over here. But yeah, this is a partially eclipsed moon, not totality. So this would be the boundary between the sunlit side and the unsunlit side. Thank you. All right. What else do we have on the, we're tired of sitting around looking at pictures. We got to get up and moving around. So if we can get the lights back on. And the first thing I want to do is point out the little balls of aluminum foil hanging above the participants' heads. Here I
Hey, people
thought-
at home, we're going to do some in-class things. I'm going to head back over to the camera, see if I can't get a wide shot of the classroom. I'll try to keep you involved as much as I can. And I will try to race around with the mic as well, unless if you can take that mic and why don't you, if you see somebody with their hand raised, just remember that people at home can't hear you unless you speak into the mic. I think we should be good.
Participants will be able to move around.
Yes, the people in the classroom are invited to do whatever he has in store for you.
All right. Wondering about these walls up here. You have an idea. Solar system. Okay, I can give you a little hint. Wall represents a star. Volunteer. Thank you, volunteer.
Tina Pollock at the house.
All right, now that last wall way over on the left is really hard to see, but I want you to stand right here. Look at those walls.
If you're at home, make sure you have your view in speaker view. And I think it's going to give you the biggest picture.
4 stars. Another volunteer.
Okay. Yeah, I knew he would do it. Make sure you guys speak into the mic and kind of let the audience at home know what you're trying to do.
Stand right here. Okay, now you see the 4 balls. On the right. 1, 2, 3, 4. Yep, that 4th one's a little bit too high.
Talking to the mic.
Oops, sorry. All right, 4 balls over on the right-hand side, and then 1, 2, 3. And that second one has 2.
Right.
Do you recognize any pattern?
But thank you for your participation.
You
Oh,
keep
we have somebody over
reminding
here
me.
that wants to guess.
No,
Do you want to go see?
which
Brian?
one is it? that's-
Okay. Brian has a guess over here, Peter.
Yeah.
Right here. Here. Oh, sorry.
Is it the Big Dipper?
Yes.
So I think everybody at home heard, but it is the Big Dipper. And I know you can't see it from home. Oh, liability.
All right, so I want everybody. I'll help you visualize this.
Okay, Peter's going to help people visualize
And
it.
I'll help you visualize this. Everybody watching at home, you have to forgive me for not remembering what I'm supposed to be doing. Now,
The most interactive class we've had so far.
There
So
you
you're
go.
doing a great job.
where this. All right. We have 1, 2, 3, 4 stars over there. That's the bowl of the Dipper. Okay. And the Big Dipper, when you see the Big Dipper upside, right side up like this, the bowl will always be on the right. Okay. The other 3 stars, and you can't see that one right there. Okay. That's the very tail of the Dipper's handle. This is the double star in the middle of the handle. And this is the bowl. So you have 4 stars making up the bowl, 3 stars making up the handle. Are we able to visualize that somewhat now? Okay, now when you walk around to the other side of the front of the room, thank you very much. You're very cooperative. You may go back to your seats now. But look at somebody, perhaps there's a being on another star on the other side of this group. They're going to see a totally different constellation. So the constellations that we see are not only dependent on what stars are there, but what our point of view is. What direction are we looking at it? If I was on a planet over here, I'd probably call this, the Great Mountain with a lighthouse on top or something. I don't know. So all of the diagrams that we imagine when we look at patterns of stars in the sky are a figment of our imagination. And if you go through history, you'll find out that some constellations like this, actually, we call this the Big Dipper, but that's not the constellation. Does anybody know what the constellation is? Ursa Major. And what part of Ursa, which means bear, is the Dipper part of it? That's the bear's, his body. And there are other stars not in this diagram, but if you saw the whole constellation, you would see that from the body, just like you said, there are stars coming down that way that you could make out as legs. And then the 3 stars over here, what are those? The tail. Some mythological stories say that some god got angry and grabbed the bear by the tail, which he wasn't always, bears don't have real long tails. So he grabbed the tail of the bear and swung him around like this and flung him up in the sky. And that's why it has such a long tail. But the whole point of this is that constellations look the way they do based on the relative location and our point of view. It's really an optical illusion. And besides, constellations will go away after a while because all of the stars in the galaxy are moving. So in a couple million years, there won't be any more. In fact, not even that long. In a few 100,000 years, they will have drifted. 100,000 years, geologically isn't very long. Anyway, any questions on any of that? Yes, sir.
We have all learned that the universe is expanding.
Yes.
How come Ursa Major has been so visible for so long?
Because so long is only so long to human existence. So long is nothing in universe existence.
But is it part of our galaxy? Is that
Yeah.
part of it,
Oh, yeah.
the answer?
Every star that you see is part of the Milky Way,
Yeah.
part of our galaxy. Did that answer your question?
Yeah,
Good.
because the galaxy is a different stability than the rest of the universe in a sense. Maybe.
Okay. I'll go along with that. All right.
It's certainly true that what we think of as a long time as human beings is nothing. I remember reading years ago that if the 4.3 billion years that the Earth existed was represented by a piece of wood 20 feet long, that the entire existence of Homo sapiens would be less time than the thickness of the paint on the end of that 20-foot board.
Yeah. Another, Carl Sagan had a similar analogy in
Speak into the
Cosmos,
mic.
where Carl Sagan had a similar analogy. I apologize, all you people at home. I'm so sorry. This is my first thing at this.
We do have a mic pack. That's why I offered that at the
Yeah,
beginning. So
probably would
if
have been a
some-
good idea.
I
Next
know.
time I'll listen
I'm
to you.
sorry.
No, it's my fault. Where was I? Carl Sagan. Well, we were talking about stars moving, and oh, there you go. Thank you. Calendar. He has the cosmic calendar on which the Big Bang happened on January 1st. Okay. And then nothing happened until October when stars started to form. And he goes all along, November, he had galaxies and whatnot. Okay. And I believe that humans appeared at like 11:59. Okay. So when you say, how long ago, not very long. And that could be a million years, isn't very long ago, really. A million is 1,000th of a billion. So if the universe is 4 billion, how old is it? 13 billion years. Yeah. That's a really long time. Really. Does that answer your question? Anything else?
Could you expand a little bit on Hemlock Crossing
Oh, yeah.
Observatory? What kind of telescopes whatever that's about?
Yes. And I didn't think to put a picture of the observatory in this presentation. And afterwards come up, I'll show you. Okay. So the observatory at Hemlock Crossing is going to be a 16 diameter dome with a 16-inch permanently mounted best in West Michigan telescope. Really, really nice telescope. It'll be open to the public, but I think I've already explained where Hemlock, hopefully we know where we can find Hemlock Crossing County Park. So now 16 feet is probably less than from me to the wall, but it'll be big enough for a observatory. So just imagine, a circular wall about that high with a dome on top, and the dome has a door in it that slides open so that when you're in the observatory, you're covered by a ceiling except with this one small part, and that's where the telescope points through. When you want to look at something else, you have to rotate the entire dome and telescope. We have poured the foundation, so all the concrete work is done. They have the utilities in, I think, water and electricity. We're just waiting, and the dome is going to be delivered on a large truck. So right now, we're still trying to find somebody with a crane big enough to get the dome box off the truck. The county didn't have one. And then members of the club will be assembling and building the dome. The company that, it's a specialized company. That's all they do. They manufacture domes for public observatories and astronomy clubs and so forth. And so there's, like a several 100-page book, instruction book on how to assemble and use it. But we hope by next fall to have public observing. It'll be really cool. It'll be even better than the one in Grand Rapids.
That's great. We have about 2 minutes left. It looks like Bill has a question.
Correct me if I'm wrong, Peter, but if I understand correctly, you're planning to have a video camera tied to the telescope, and what the telescope sees, you'll be able to watch on a screen inside the building there. Is that still?
I'm not sure whether that's a set in stone thing or whether it's on our wish list. But we did receive a very generous, wonderful donation, last fall, just I think it was in September. And that allowed us, or that will allow us to buy lots of goodies, like a solar. We want to be able to do solar scope and what you just said.
I have a great question from home. Peg is asking, how will interested parties participate in the use of the Hemlock Crossing's telescope?
You would have to follow look for information on both the Hemlock website and the SAAA website. And there you will find the times and days of observing. And other than that, you just show up. And probably, we've had a lot of discussions about this because none of us, very few of us have very much experience with this sort of thing. So, we don't know. I mean, you can't let 50 people into the dome. And then if you've ever been out to the state park, you know how it is. You got a line of 30 people. Well, if you give every person 30 seconds of time looking through the telescope, it's going to take 15 minutes. Who wants to stand in a line for 15 minutes to look at something for 30 seconds? Well, a lot of people apparently do. But but we have the same problem at the observatory. Of course, you can open the observatory, people can come in and wait their turn. We still haven't worked out the logistics of how many people we're going to let in, how many different things we're going to look at. We don't know, if inside the dome, you still have to wait 10 minutes to get your 30 seconds of telescope time. So, and we don't want people going in and out because then you have to open the door and turn the dome and let light in. So it'll be a learning experience for us, but.
Okay, well, it sounds like people have some resources to follow you as you go through that process of figuring out what the process is. So with that, it looks like we had a lot of great questions answered. Wonderful presentation. Thanks everybody at home for your patience and everybody in the classroom because this was a new learning experience here with a lot of visual aids, but hopefully this will not be the last time that we have such a great interactive class. We thank you so much.
My pleasure. Thank you.
Thank you, everyone at home. I'm going to go ahead and close the class.
Thank you. Thank you very much.